It's right at noon. So with that, I'd like to introduce Roy Sturgill. Roy joined us in 2019 as an assistant professor. Roy came to us from the University of Kentucky. He's been an outstanding member of our faculty since joining us, and he's really pushing the envelope in terms of technology in the construction world. And with that, I'd like to turn it over to Roy and look forward to hearing your questions at the end. Thank you.
Hello, I'm the digital persona of Roy Sturgill. I'm here to welcome you to today's webinar on technology's role in transportation construction. So without further ado, I'll introduce the real Roy Sturgill.
Well, thank you, and welcome to everybody for today's webinar on technology's role in transportation construction. I would like to start the talk today with this figure that really captures the synthesis of what I'm going to talk about. So this is two photos on Easter morning, so around the time of year now. And one is from 1900 of Fifth Avenue in New York City on the left. And what you can see there is a lot of horse-drawn carriages with one horseless carriage, as they would call them at the time. And then 13 years later, on the same spot in New York City, you see a street full of cars, automobiles, and with only one horse-drawn carriage. So the intent of the picture is to show in such a very short amount of time the advancements that had occurred, the things that people were using, the ways that technology had changed society. And so that's sort of what I want to talk about today, is how technology has changed transportation construction. And I want to tell the story through my own timeline. As David mentioned, I joined Iowa State in 2019 as an assistant professor in our construction engineering group. And prior to that, I started at the Kentucky Transportation Cabinet, which is the DOT in Kentucky, in January 2007. And so at that time, I was in the field quite a bit. I conducted construction inspection. I managed construction projects, had to do a lot of documentation, a lot of measurement, a lot of making sure that the contractors were getting paid for the work that they were doing, the work that they were installing. And so some of the primary tools of the time, the technologies that I was using out in the field were things like a tape measure. Any inspector was going to have a tape measure pretty close at hand. You went everywhere with your field book that you filled out with information about conversations that took place on the job site, the amount of materials that went in that you measured, what things need to be paid for, any kind of issues, documentation, those type of things. And you also, at the time, would find folks with just a normal digital camera so that you could document those things. As time went on, we did have an electronic construction management system. And so that was an Ashtoware product. It was a site manager, but you didn't really have much access to it out in the field. You would use the field book, take your notes, and then when you got back to the office or maybe the next morning, you would transfer your notes, transfer your measurements, transfer all that data into the system. And the system would have the ability to do reporting. It would have the ability to help generate payments to the contractor. It would have the ability to process certain things with some level of automation and workflow, but still pretty high level. At the same time, I've kind of counted myself as being lucky to get a state issued cell phone. And so pretty early in my career, around 2008, so about a year after or so after I had started, I was issued a Nokia phone like you see in the picture that had very low functionality. Essentially, you could just place phone calls. We actually weren't supposed to be using it for text messages at the time. So a pretty low level technology mobile device out in the field. But a few years later, I was actually issued a BlackBerry. And so if you don't know what a BlackBerry is, it's a mobile phone that had a full keyboard integrated into it. And it was a useful piece of technology. I at least enjoyed it. Wish I still had my BlackBerry some days. But it was quite a bit more functional. You could respond to emails, could enter in information pretty easily. And so that was a decent piece of technology that I was issued while being at the cabinet. I will also say that, and the reason I bring this up is we're going to talk a little bit about technology implementation today as well. And the Palm Pilot that you see there with the stylus is an example of a technology that we tried to implement at the Kentucky Transportation Cabinet, and it was pretty much a failure. So there was a program, an application on that Palm Pilot that could integrate with the AshtoWare Site Manager software that we used. And if you wanted to type in your daily work report out in the field, you would meticulously use the stylus and enter each letter on the keypad that popped up on the screen to type in your work report. Some of the issues there were related to people, some technology, and some process, and we'll talk about more of those issues with that particular application a little bit later in the presentation. So in October of 2012 is when I actually left the Transportation Cabinet. I went to the University of Kentucky as a research engineer in the Kentucky Transportation Center. And shortly thereafter was really when I became to get interested in technology. And so one of the first pieces of technology that we started researching, and where I really found this passion and love for researching technology and construction, was when we got to operate what we called drones at the time, or unmanned aerial systems. That was essentially some kind of quadcopter with a camera, and you could do some very fascinating things. We at first were just using them for aerial photography or videography, but then we found that you could actually use some software such as Pix4D, which was used to capture the model video that's being played there. And with that software, you could actually do photogrammetry. The GPS on those unmanned aerial systems was advanced enough to where the photogrammetry would actually come out pretty well done. And with some ground control points, you could actually get some really good data, which was the source of the paper that you see there, where we looked at estimating earthwork volumes through use of the photogrammetry that was captured by drone. So in terms of the role of this particular technology in construction, you could use it to estimate how much earthwork was done in a given day by flying the site in the morning and flying it in the afternoon. You could do earthwork volume differences between the two times. Now, I will say one of the issues that happened there, and I'll fully admit that maybe there were some things I did that FAA wouldn't be exactly happy with the drones. We did fly over traffic before there were rules and things. So in June of 2016, the FAA really issued guidelines, because what they didn't realize, and some of these things with technology advances so quickly, we don't have the rules or processes in place to implement them or adapt to them. So this is an example where the policies weren't there. These drones looked a lot like toys, and they were being used for pretty advanced purposes. And so the FAA had to come out with a policy, and that policy included, folks being trained on how to use these things appropriately and safely. And so when that happened, rather than myself get licensed to be able to be a drone pilot, we kind of shifted that off to folks in our group that already had pilot licenses. And we kind of moved on to the next thing. So as you'll watch these timelines as we continue on, you kind of see some of the advances that are taking place, just like going from the horse-drawn carriage to the automobile. So between 2015, 2016, one of the things that we looked at was the use of mobile IT devices in the field of construction, design, asset management. And so this kind of goes back to the cell phone and BlackBerry that I was issued when I was at the Kentucky Transportation Cabinet. So in this study in 2015, 2016, we did a canvas of all the state DOTs to determine what they were using in the field. And as you can note, 84% were using some kind of device out in the field, but there was still a good portion that were not. And there was a good spread about whether it was a bring your own device type policy, or whether it was an issued device, or what the device was, whether it was an Apple device or an Android device. There was all sorts of variation because the states were still trying to figure these things out. And for the most part, the use cases of this technology were just to answer emails, make phone calls, send text messages, and to a lesser extent use them in some more advanced ways, such as geotagged photos, used for GPS, or even in a very small number of cases to view 3D models, which is something that we're looking at a lot more now. The next thing that I kind of got involved with was around 2017, there was this discussion of e-ticketing. And so e-ticketing is basically for bulk materials, whether it's aggregates, asphalt, or concrete. The way that DOT jobs would work was the material would show up, the truck driver, the hauler would hand you a paper ticket, and you had to keep track of those tickets to determine how much material was delivered on site and verify that that was the adequate or proper amount that was delivered, and that was what was paid for. So around 2017, it was actually the Iowa DOT who really pushed this concept of e-ticketing. It was out of safety, out of documentation purposes, out of kind of data continuity. And so you went from having these paper tickets to things being in a cloud and data flow happening kind of automatically. And so those tickets became e-tickets that could be accessible by anyone with a mobile application and cellular service, or in an office that had access to the internet to look up, what tickets were being delivered and accepted out on job sites. And so one of the things that we did in advance of, or in addition to e-ticketing, was we tried to couple e-ticketing with some other technologies to see how much we could support our field staff. And so that's another role of technology, is to support your staff in the field or your management staff uh, with being more efficient, having better data continuity, more details, those sort of things. And so this is one of those examples where we used another system called PaveIR, which is a payer-mounted thermal profiler. And you can see there in the lower photo on the left, a bunch of bands. You've got some green bands and some yellow and red bands. And what that's showing is the temperature of a pavement mat, the full width of the pavement mat, and the green is cooler temperatures. You're also seeing below that a bar graph that's showing the paver speed. And so you can see wherever the paver slows down or nearly stops is where you're starting to get colder spots in the pavement. And so that might be in between trucks or what have you. But a colder pavement is not good for the quality of the pavement. And so you were able to use this technology to really identify potential issues with improving the thermal continuity and those type of things. We also used intelligent compaction rollers, not for their compactive numbers that they were providing, but to monitor the pass counts or the coverage of the roller on the mat. So with these three technologies, e-ticketing, the PaveIR system, and intelligent compaction, we were able to couple those together and provide either a engineer or an inspector a lot of data that they otherwise would have had to collect more manually, but this was all being collected through the technology. But this e-ticketing concept was something that really took hold, continued to look into it, and actually did another nationwide canvas to determine how states were using it. At the time of this synthesis project, Synthesis 545, there weren't maybe a couple handfuls of folks who were experimenting with e-ticketing or using it. There were states like Iowa, Florida, Pennsylvania, Kentucky that were really starting to try and ramp up their use of it. But it was still kind of new. At the same time, I was fortunate enough to be asked to be part of the Everyday Counts initiative as a subject matter expert on helping to ramp up the use of e-ticketing. And while certainly that increased the use, there was one thing that increased the use of e-ticketing more than anything else. And so I'd call attention to the COVID-19 pandemic. A lot of times we talk about the pandemic in a very negative tone. However, as technology is concerned, the pandemic really pushed us into making use of some technologies that were just on the forefront, just getting used preliminarily, and e-ticketing is one of those. Virtual meetings. Think about before and after the pandemic, how much more we are using technology day to day. And so that was one of the positives, was it really pushed states to adopt the e-ticketing concept. And so from 2017 to 2022, saw just a dramatic increase in e-ticketing, such that it became, as part of the Everyday Counts program, the #1 most implemented technology of any technology that was part of Everyday Counts. So that's quite impressive. Continuing on with these synthesis projects, another project that I was able to do in the 2021-2022 timeframe was highway infrastructure inspection practices for the digital age. And what I wanted to call the attention to here is that from that early mobile IT synthesis to this synthesis, we really start to see mobile devices in the field become commonplace. And we start to see some of those more advanced uses such as them being used as data collectors, being used as to collect geotagged data, or use for viewing 3D models or 3D engineered models, or in BIM practices, really starts to ramp up compared to that previous version of the synthesis that was completed. So you see how these technologies in a very short period of time are being advanced in use. And one other project I was fortunate to be part of was the application of RFID and wireless technologies in highway construction and asset management. And as part of this project, we looked at 10 different technologies and how they were being implemented in the field. We first looked at, based on their use cases, their amount of use by DOTs and that sort of thing, and assigned them a readiness score. But this is really where the concept of the importance of people, process, and technology were highlighted to make us understand and see that implementation isn't just about having a good technology. You really have to make sure that the people who are using it at all levels, all the stakeholders, understand what the purpose is, how it's being used, how it might be useful to make their job easier, more efficient, collect richer details. There needs to be buy-in into the technology. The other thing is the technology has to be mature and ready for the implementation process itself. So a newer technology that may have some quirks or bugs in it, that's going to frustrate people if it's not ready. So the technology has to be there. Also, the process has to be prepared for any kind of workflows or digitalization of the data that's coming in. There needs to be a place for that information to go, and there needs to be a workflow to help it go from one person to the next through the process. So the importance of people, process, and technology can't be overemphasized when it comes to implementing technologies, especially in construction. So we'll go back to the Palm Pilot that I mentioned before. The technology wasn't quite mature. There were issues with it where you could type in your daily work report, and I did this on a couple occasions, where you typed in the daily work report, and as part of the workflow process that was set up with the technology, step one was to delete your records. Step two was to allow the record to process through. So if the workflow of the data from the Palm Pilot to the computer got disrupted by some issue, which happened frequently, the record was gone. And so many people lost, the time that they had spent in putting that record in out in the field. So the technology wasn't quite there. The people weren't really ever trained or shown how to use this. And quite honestly, what feedback we got in central office about the Palm Pilots out in the field was that they were often just used to play solitaire. So the people need to understand how to use the technology and how it can benefit them. And then finally, the process has to be set up to where it is efficient. The data flows completely without being deleted or lost. And so all those three things have to work together. And so that was a really key project in kind of taking the next steps with technology to making sure that implementation can take hold and take place. So that was completed relatively recently, and now some things that I'm looking at include 3D models. So currently I have an NCHRP project 10-111 that we're trying to develop a guide for 3D model viewers for construction inspection. And so there's lots of different model viewers out there. Some in the vertical sector are using like the XR10 hard hat with HoloLens from Trimble that you see in the photo on the right. The example video on the left is an example of using the Apple Vision Pro. There's also the Meta Quest and several other face-mounted 3D model viewers that are out there on the market. But for the transportation sector, really the finding is that you don't want anything that's face-mounted when you're working at a live construction site in the field for transportation, near traffic, near hazards such as those. And so really they're moving more toward tablets. So tablets with a 3D mounted, with a 3D model viewer that you can manipulate and still see that 3D model, but you don't have anything impacting your view or your vision. So that's one project we're looking at. Another project is how do you collect the data for the model? There's some work that I have ongoing where we're using an iPad or an iPhone with a device called ViDoc, and that ViDoc actually makes the GPS of the iPhone or the iPad RTK corrected. And so it's a little bit like being a surveyor, but it's not, because we're not licensed surveyors, and it is actually bothering some of the surveying community about how accurate the data can come in and how it gets represented. So you have to be careful about not representing it as anything that's been surveyed, but you do get these using photogrammetry, these 3D models that in some cases, when the satellites are right and you're keyed into a base station or a CORS network, you get the correction such that you have accuracy to less than 3/100ths of a foot, all by just walking around. So the example here, you have a 20-foot or so pipe that, in walking around that trench, which took 20 seconds, we were able to get a 3D model that is accurate to within 3/100ths of a foot. So very exciting things that you can do with technology to enhance the richness and detail of data that you collect in the field. Some newer projects that are just starting, part of what the Federal Highway Administration is doing to really try to increase technology's role in transportation, is by putting out the Advanced Digital Construction Management System grants. And so ADCMS grants were issued a little over a year ago. I'm fortunate to be part of 2 of those grants, and they're really exciting, and there's really some great things that are coming from them. The first one I'll talk about is with the Delaware DOT. And so this project includes project partners from Hall Hub, WAP, other DOTs such as Nebraska DOT, Iowa DOT, are all part of this team where we're looking at how data collected from the equipment, from the construction equipment, can inform and be used by the owner, by the DOTs, for their purposes. And so some examples already that are being used are automated safety feeds, where if a paver is operating, or if there's rollers operating, it keys in and lets Waze know that it's not just a construction site, it's an active construction site. And there's people on site that you need to slow down and be cautious in those areas, or even it can, Waze can help to reroute traffic around those zones. The other thing that's quite interesting is that the data is being fed in from the construction equipment, and we're able to use AI to generate work reports. So we know where the paver is operating from one point to the next. We know how much material is going through the paver, through the e-ticketing. And so AI is generating a work report that an inspector can just go in and manipulate some details to make sure that everything's correct. And so really building some efficiency and some time saving in for those folks as part of this project. And there's more to come. We're just now starting to look at what data we're able to capture from the different pieces of equipment. The other ADCMS project is with the Iowa DOT. And with this project, we're looking at how we could advance digital delivery in Iowa and beyond. And so we're looking at, from construction, all the data that we're collecting, how do we make the workflow and the process seamless to where the data flows through the life cycle of the asset. So from design into construction, into operations and asset management, and then back around when we go through that next level of project. So how do we collect data automatically? How do we use it for design? How does that design go and inform what's done in construction? And how do we provide updates to that data that then goes in and informs asset management and around the cycle again? So sort of to sum up the role of technology, what is the role of technology in transportation construction? It's to increase efficiency, accuracy, speed, to be a resource, and to maximize the resources that we have in the field. We hear so much about staffing and workforce shortages. Technology is trying to fill that gap. And so it comes back to understanding the technologies and the applications, the people, process, and technology of how we can implement these things and then be effective. And I wanted to just kind of come back to the fact that it also seems like all this is really speeding up. If we think about the industrial revolutions, So if we think about Industry 4.0 and 5.0 that's coming or that's here, you look at the dates there on the graphic, and if first industrial revolution was considered to be 1780s, the second 1870s, the third 1970s, and then the fourth in the 2010s, and now the fifth, we're really seeing those revolutions happen faster and faster and faster on a shorter wavelength because technology is growing and moving so quickly. And so to kind of close up my presentation before we go to any questions, I take us back to the first slide that I started with. If you think about the technology that I just explained through what I think is a fairly short career for me, it's within a window of time that's not too different from what you see here. So instead of going from horseless carriage to the automobile, we're going from paper plan sets to 3D models in virtual reality. So with that, I appreciate everybody's time, and I'll turn it back over to David for moderating any questions.
Thank you, Roy. Fascinating in terms of the evolution and changes that we see in technology. Thank you very much. So the floor is open for questions if anybody would like to ask one. Or Roy, maybe I'll ask one while we're getting things ready. How is the training going in terms of getting people to, you talked a little bit about training. Are you seeing lessons learned from the previous types of evolutions that we've gone through in terms of how we're bringing people up to speed with these new technologies?
That's actually a really good question. In looking at technology, the thing that you learn is that, especially within DOTs, a lot of DOTs have different processes in place, different workflows in place. So to some degree, the technology, the training always has to be catered to that specific DOT. So what used to be kind of when you'd implement a technology, you may try to use the vendor to provide training. The finding was that it's better to develop your own training from what the vendor might provide you, just to make sure that it's a key fit. Otherwise, you might be training on something that doesn't fit, and then it causes frustration and those type of things. So that was a lesson learned from early implementation, was that the training part really does need to be well done to support the implementation.
Thank you.
Yeah. So the question is, what are some misconceptions that non-technical boards and commissions have for this technology, where they may resist technical spend and advance to advance their staff? So I think, yeah, there certainly is a cost to some of the implementation of some of these technologies. And I'd kind of go back to the project that I talked about, where we discovered that with implementation, it's important to understand the people, process, and technology maturity and aspects for an organization. But one of those things that isn't mentioned explicitly there is the consideration of cost. And so with any implementation, sort of the best approach, or kind of best practice, is to put together a group that does look at factors that include cost. So having a technology implementation board is a good example of a best practice, where you have a group that looks at cost, looks at potential savings, and before you really take next steps with the implementation, you look at the pros and cons and kind of weigh if there's a benefit to be had, and if there is, then you start moving forward with how you bring your people or your process up to speed and up to par with the technology, so that you can have all three at a maturity level that would ensure a successful implementation. So good question. Yes, cost is certainly a factor to consider. And in terms of how someone might make that sell, you do need a champion that's going to be there to say that there's savings to be had with a particular technology, and that's going to want to see it through. So I think in terms of how you make that sell is about showing the savings that can be achieved with the technology. So another question is, are you seeing differences in how the different construction industries are evolving? For example, vertical versus transportation. I would say absolutely. So when we have the discussion about 3D model viewers, you know, that can be considered somewhat of a mature technology for the vertical sector. In the highway sector, we're just now starting to explore how that can be implemented. It's actually an interesting thing about the project that I discussed was that initially we were thinking that we were looking at more advanced uses of those 3D model viewers for how you would use the viewer to make measurements, how you would use the viewer to document or augment the model, like update it with data. And what we found was that for the most part, the DOT sector isn't really even ready for those advanced uses. Their staff needs to be able to understand how they're going to be able to cut cross sections and view the model in like a plan view, so that they can make the transition from paper plan sets to a 3D model. So those are some things that, you know, at first you kind of look past them and to the more advanced uses, but you have to reel back to, hey, how are we going to make use of these out in the field, and help the folks that have been using paper, you know, plan, profile, and cross-section views for so long. How are we going to help them transition to seeing those same things within a 3D model? And I think the vertical sector is way past that step. Do you know of any research incorporating structural health monitoring systems into BIM or FIM for asset management? Yeah, so the kind of the structural health monitoring aspect kind of takes that 3D model from a BIM. So, you know, BIM is building information modeling, and for infrastructure, they kind of say BIM for infrastructure. And with that, you've got a 3D model that you're adding attributes into. So the sizes of beams, for example, the types of material that are used. You can tag in. We're looking at tagging in an e-ticket to a particular place that material was placed. So that's kind of the BIM. The next level is the digital twin, and that's where you would draw in the structural health monitoring, where you tie sensors into the BIM model or the 3D model, and that's where the model itself can start to perform and act like the uh, structure, you know, in real life. And so you can do some testing and things. The best examples of that are with some of more of the utility systems, where you have a water system or a power system, and those systems are a little bit easier to model and have more, I would say, nodes for sensors than maybe a bridge or something like that. We're really early on, I think, in outfitting bridges with all the different sensors and monitors that could go into place to feed a digital twin of a bridge. But that is something that's coming.
There was also a question from John Roy about what resistance to implementation are you seeing with the DOTs? His experience is some DOTs are more progressive than others in terms of technologies.
Oh, yeah, for sure. And I think you know, the thing with DOTs, I would say, in terms of resistance to technology is um, they're resistant if they have the means to do the work they need to do otherwise. Um, I think what I'm experiencing is that a lot of DOTs are becoming more open to technology, and I think that, you know, my opinion is that's largely due to the workforce issues. I think a lot of DOTs are realizing that they've got to be more open to technology as a supplement uh, to the workforce, to help their workforce be more efficient, to do more. Um, and so I think if a DOT has the resources they need in terms of staffing and that sort of thing, they may be a little more resistant to technology. But for the most part, what I'm seeing is that they're becoming more open to it. And I think programs like the Everyday Counts program from FHWA, and examples of successes of using technology are helping to drive other DOTs to follow suit. We have another question of, do the technical advances help in recruiting CE and Connie students away from other engineering disciplines? we've been traditionally slower to adapt technology. I think that I think certainly, when we go to recruiting events and there's technologies that we can show, I think that does help to sell the discipline. Um, but I would also say that there's a lot of faculty in our department that are currently, uh, looking at ways that they can bring technology into the classroom. You know, I, for example, have been bringing the Trimble XR10s with the HoloLens into the estimating class and having students look at the model of town engineering building and do some measurements of the building, sort of like a takeoff in a 3D model. And so we're including more of that into the curriculum, I think, and that's certainly you know, it's piquing the interests of the students that we already have, and I do think that being able to show that in different areas for recruitment is helping to draw students in as well. I think that's the key for a lot of different engineering disciplines, but certainly for things like construction and civil engineering, um, we need the technology to help us draw in that next generation. Because if you look at generational trends and interests, that next generation is very tech savvy, and they're looking for technology to make their lives easier. And so we need to have that and show that it can be part of our discipline.
One of the things that we've done as a department along those lines is Roy has been helping us out with the booth that we have for prospective student visits and for high school students that are coming to visit Iowa State, as well as undeclared students. And we've tried to upgrade that area so that we're showing these types of technologies through interactive a display with showing 3D renderings and how you can fly through different construction sites or a project to try to give people a taste of the way civil construction and environmental engineering is utilizing new technologies. So a great point.
Got another question of, are we starting to acquire data to understand how these technologies are impacting construction productivity? I would say yes, that there are um, um, studies out there showing that technology is improving efficiency. It's helping workforce do more. We had a study I was part of looking at staffing for construction projects, and we actually put together a list, kind of a booklet of different technologies that could help supplement um, staff for construction inspection. But we're also seeing that in the equipment itself. So I didn't talk a lot about how, from the contractor's perspective, the telematics and the automated machine controls that are part of making the contractor more efficient have been around for a long time. And actually, the ADCMS project with Delaware, we're communicating with the equipment vendors to give them the other side of the story. So for years, they've been hearing from the contractors wanting to be able to automate what they're doing and make their increase their productivity through um, you know machine guidance, machine learning, AI, all those different technologies to make them be more productive. But the other side of the story is, hey, the DOTs could use some of that data too. And there may also be some things that could easily be captured um, that would help the DOTs be more efficient as well. So that's one of the things that when we're talking with those equipment vendors, like, oh yeah, we can capture that, whatever that piece of data is. It just wasn't something that the contractor was interested in. So I think that project's really neat to hear from the contractors and from the equipment vendors that there's a lot of low-hanging fruit that we can go out and get for the DOTs and really kind of make it a more collaborative environment. And I think that's another benefit of technology and construction, is it helps us to be more collaborative between owner and contractor and the other stakeholders of the contract.
Maybe one other comment on technology is yesterday, there's been a lot of talk about AI here on campus and certainly as a technology. I went to an open house yesterday for our AI Technology Center here on campus, just to see the wide number of projects now that are integrating AI into decision-making processes through all sorts of disciplines. Roy, have you seen that type of technology into the civil construction and environmental engineering sectors yet?
Yeah, so you know, even some of the more simple AI, you know, the kind of the chat GPT type of language processing, you know, the Delaware project has demonstrated that through the information that's coming in from the construction equipment like the paver and that sort of thing, they're able to generate a storyline of what's happening on the project. And then that can be issued both as like a safety feed of, hey, you know, there's a paver at this mile point that's operating at this speed going this direction. But it can also be used to generate text for things like daily work reports. So now the inspector, instead of having to write in that orange notebook that I showed on one of my first slides, or type it into a tablet or an iPhone, they're able to just get an automated report, check over it, make sure it says what they want it to say. They could supplement it or add to it or edit it however they want, but it's being generated with AI. So there's a lot of ways that technology is kind of helping to build some efficiency into construction as well.
Well, I want to thank all of you for joining us today, and I want to especially thank Roy for taking the time to do this webinar. If you have any additional questions, I'm going to volunteer Roy to feel free to answer those questions. Please reach out to Roy if you have any specific questions. Before I close out, I wanted to show you a couple of more slides. So we're still working towards expanding town engineering to the south. Town engineering was built in 1971, was initially shared between aerospace engineering and civil engineering. In 1999, aerospace engineering moved out of the building, and we now essentially occupy all of town engineering here on the Iowa State campus. But as I mentioned, the building was first occupied in 1971, which means it was designed in the late 60s. So things, just as Roy's talked about, technology changes. There's been a lot of changes in technology of teaching in the last 50 years. And so we're looking to expand to the south, but it's a fully non-state funded addition. And so we're in the process of raising $33 million. If you'd like to know more about this project, please feel free to reach out to me, David Sanders, or to Gary Sutherland, who's on this slide, and we'd love to talk to you about opportunities for helping us with this project. So with that, I'd like to close this webinar. And again, thank you for joining us. Please stay connected with us. We have social media through LinkedIn, Instagram, Facebook, but you can also pick up the phone and call us. We'd love to have anybody come back to campus and share your experiences with our students and with our faculty. So feel free to reach out to us in that way also. So have a great day and go Cyclones. Thank you.